So the graph of cosine is actually really similar to the graph of sine. I've actually graphed it right here next to our original blue graph of sine is our red graph of cosine. And it follows the same overall pattern, but it's slightly offset. And the reason for that is that cosine is really just the complement of sine. So it's offset by 90 degrees or by pi over 2. The graph of cosine follows all the same beats, but rather than starting at 0, cosine starts up at its maximum value of 1. And then it goes through the same overall pattern. So it passes through a 0, down to its min, and back up, and kind of flips around, and then continues around and around and around in both directions. It also has an amplitude of 1, so it's bouncing between -1 and 1. I'm just going to make my -1 line up a little bit better. Okay, so it bounces between -1 and 1, and it follows that same pattern. The main difference is its starting and stopping position. To get a better sense of these two graphs, I'm just going to focus on one period of each of them. So I'm going to flip this over. I'm going to look at the graph of sine and cosine, each over one period. And both share the same period of 2 pi. They cover a single cycle over that distance. And there's really 4 key values that each of these graphs pass through. So I'm going to refer to those as the key points. The key points occur in 2 places. It's either the turning point or where the value crosses the axis, so the 0 of the function. So I can see sine starts at a 0, then proceeds up to a turning point, passes back through a 0, down to another turning point, and back to 0. So sine passes through 3 zeros along its period. Whereas cosine starts at its turning point, so it only has the opportunity to pass through 2 zeros along its period. Okay, that's the main difference. They both have the same amplitude. They both have an amplitude of 1 and a frequency of 1 and the same period. It's just where do they start and stop? That's the main difference between them. So let's look at an example of how we can actually graph these functions. So I'm going to go to my calculator for a second, and I'm going to clear out cosine, and I'm going to write down the first example we're going to work on. This is actually example 7 in your unit packet if you want to use that page to follow along, or you could just do it on a piece of graph paper. But it's the equation y equals 3 sine of x. Okay, now to help me with this, I'm going to identify some identifying features, namely the amplitude, the frequency, and the period of y equals 3 sine x. So the amplitude, well, that really is determined by that coefficient of the trig function. So this has an amplitude of 3. It's going to deviate 3 times more than just the regular sine function from its average. The second value that I'm going to identify is the frequency, and we've seen that that is the coefficient of the x value. So I have a frequency of 1, because that's really the coefficient of x there. The period, we derived a formula for this. It's 2 pi over the frequency. So for this example, that would be 2 pi over 1, or just 2 pi. And what this is the length of a single period. So by the time I get to 2 pi, I should have completed one cycle of this trig graph. Okay. Now I'm actually going to graph this in the calculator so I can confirm this. So I'm going to do y equals 3 sine of x, and I'm going to graph that and compare it to my original sine graph. So my original sine graph is going to come up blue, but 3 sine x is going to come up red. So when I click graph, I have my original sine graph, and there is 3 times that original sine graph. So it's 3 sine x. And notice it's 3 times taller, and that's what the amplitude refers to. So when I'm graphing this, it's really going to have the exact same pattern as the sine graph, just rather than going up to 1 and down to -1, it's now going to go up to 3 and down to -3. Additionally, for this graph, I'm going to graph 2 periods. So I'm going to sketch 2 periods rather than just 1, so I can get kind of a better picture of the graph like the calculator provided me. Okay, so I'm going to draw a set of axes. I'm going to leave myself enough space that I can get to at least 2 periods. So I'm going to extend out a pretty far direction on the x-axis. And I'm going to scale these axes out. So I'm going to scale, I'm going to go 1, 2, 3. So I can see I'm going up to 3 because I have an amplitude of 3. I'm going to go down 1, 2, 3 to -3. Again, because I have that amplitude of 3. And that amplitude is the deviation from that axis or that average value. In the x direction, if I want to graph 2 periods, and each period has a length of 2 pi, I'm just going to count out enough boxes so that I can get 2 periods in here. So I'm going to go maybe 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to call that 2 pi, so that's where 1 period will end. And then if I want 2 periods, I have to go another 8 boxes to leave space for a second cycle. So 1, 2, 3, 4, 5, 6, 7, 8. So I'll go up to here. Okay. Let's adjust the camera for a second. There we go. Okay. So if that's 2 pi and I go a second full cycle, it's another 2 pi. That means the end of my second cycle should happen at 4 pi. So I want 2 full cycles. Each one's 2 pi, 2, 4. Okay. Now, to get this graph, I want to make sure I get all these key points. And I'm going to notice something about these key points, is that they are occurring every quarter period. So the key points are every 1 quarter period. And there's a reason for that. In order to complete a full cycle around this graph, I have to go around the unit circle, and the unit circle passes through 4 quadrants. So I'm identifying each of these 4 quadrants. That's why every quarter of a period, this key point's occurring. So when I go to do this graph, in a single period, I'm going to scale this out into 4 equal parts. So I have 2 halves, and then each half in half will give me 4 equal parts. And I'm going to do that for the second period as well. So I'm going to cut this period in half. So if I had gone 8 boxes, I go 1, 2, 3, 4 boxes. That's a half. And then half of that, 2 and 2. So that gives me 4 sections. Now those 4 sections correspond to the 4 quadrants that I'm passing through, which is where those key points are occurring. So because this is a sine graph, I'm going to follow the sine graph pattern. This is a sine graph right here. And it starts at its 0. That's my first key point. The next key point occurs a quarter of the way through its period, and it's a maximum. So I'm going to come over here. The next quarter through the period, the next key point occurs at its max. Here the max is 3, again, because the amplitude was 3. Then I'm going to go back to my sine curve. The next key point, halfway through its period, passes through the axis again. The next key point is at the minimum. So the next key point, I'm at the minimum, which is -3. And then I'm back to 0 for the last key point. That gives me 1 cycle of that sine curve. Now, if I wanted 2 cycles, I have to basically just repeat these exact same values. So as I look at the graph, starting at 2 pi, I'm going to start repeating. So at 2 pi, I get the 0. So that's why I have these 2 points in the same place. At the next key point, if I slide over, I should be up at a maximum. So I should repeat that exact same value. Okay. At the next key point, I'm back through the origin again. The next key point, I'm down at the minimum. So I'm just repeating the exact same values I've already plotted. And the next key point, back at the 0. And that gives me a second cycle of that sine graph. And because I only asked for 2 periods, I can stop there. Even though the graph does technically continue in both directions, repeating these patterns over and over again, I'm only graphing those 2. Okay, let's look at another example. What if I had a frequency change? So I'm going to slide this down. And I'm going to look at question number 8. Okay, let me make that a little bit clearer. Question number 8. So question number 8 is y equals sine of 4x. Okay, so I'm going to identify again that key information, the amplitude, the frequency, and the period. The amplitude now, that coefficient is 1. The frequency, the coefficient of now the x is 4. And what that means is that this graph is 4 times more frequent. So in this same distance of 2 pi that this graph went, which had a frequency of 1, this graph should now complete 4 cycles. So it's completing this more frequently. And that's why when I calculate the period, the period here, if this is 4 times more frequent, if it's 4 times more frequent, I'll have to complete a cycle in 1/4 the time, which is 2 pi over the frequency, which in this case is 2 pi over 4. Or pi over 2. So rather than taking 2 pi to complete 1 cycle, this will actually complete a cycle in 1/4 the time, or by pi over 2. Okay. So if I look at the graph, I'm going to go back to my y equals on this graph, on this calculator, and I'm going to type in sine of 4x. So I'm overwriting that one that we just graphed. So remember, sine x has a frequency of 1, so it completes one cycle by the time we get to 2 pi. So when I graph this, the blue graph is sine x, that red graph is sine of 4x. See how it's completing 4 cycles by the time I get to one cycle in the original sine graph. So that's important. So when we graph this, when we scale this out, I'm going to have to, rather than scaling all the way up to 4 pi like I did here, I'm going to have to stretch out my scale so that I can see the graph a little bit better. Okay, so let's see how that boils out. So I'm going to draw an axis. Okay, now this only has an amplitude of 1, so I only really have to go up 1 and down 1. So I'm just going to skip a line to give myself a little bit more space to graph. And when I scale that horizontal axis, if I'm graphing 2 periods, I want to make sure that I give myself enough space. So I'm not going to go right here and say pi over 2. I'm going to go all the way out to, I don't know, let's say maybe 4 lines. 1, 2, 3, 4. So I'm going to say that's the end of my first period. If I want to graph 2 periods, I'm going to go another pi over 2. So it's another 1, 2, 3, 4, which will take me up to pi. It's pi over 2 times 2. Just like before, when I look at that graph of sine up here, it has key points that occur every quarter period. So when I'm scaling this out to help me with my graph, I'm going to take that individual period and I'm going to break it into 4 parts. Same here, I'm going to take this period and I'm going to break it into 4 parts. And each of those hashtags, each of those parts represents a key point on this graph. Again, for sine, we're going to start at 0, go up, back to 0, go down, back to 0. So I'm going to transcribe that pattern. So the sine graph starts at 0 at its first key point, up, next key point back to 0, next key point down, next key point back to 0. That gives me a single cycle of that graph. Okay, I wanted 2 cycles, so I'm going to repeat that pattern. So I have 0, and I have max, 0, down, 0. Second cycle of my graph. And that gives me 2 full cycles of the sine curve.